Hi there, this is Professor Eckhouse, and I'm going to talk today about factoring special cases. And I'll show you what I mean by special cases in just a moment. But we're not going to be doing negative or fractional exponents, and we're not going to do factor by substitution. So those are two things that are in our book, and we're not going to do them. All right, so let's start with a little warm-up. Just pause your video and work these two out. Okay, so hopefully you gave this a try because this is a really important mistake that people make all the time. Very, very common, really important to understand why the mistake is not true. So what I see most people do when they first start this is they say, oh, well, this is x squared plus y squared. It is not x squared plus y squared. It's so not that I'm going to erase it. Okay, I don't want you to even look at it for another moment. It's not x squared plus y squared. All right, so it is. What this means is the quantity x plus y times itself, x plus y. Once you've done that, hopefully you see that you're going to factor it. So first is going to be x squared. Then the outside is plus xy, and I'm going to put the x first both times. And then the inside is also xy. And then the outside, the last is then y squared. All right, so what does this become? It becomes x squared plus double xy, 2xy, plus y squared. All right, so you're going to get the same thing here, the next one, x minus y squared, except there's going to be a minus somewhere. So squared means we multiply this times itself twice, and then we're going to FOIL. So we get x squared. And then we've got outside is x times negative y, which means minus xy. Inside is x times negative y, which is minus xy again. And then the last is negative y times negative y. And that's going to give us positive y squared. So now a common question is, why is the last term positive? Well, think about it. You've got negative y times negative y. All right, so then we get x squared, and then again double the minus xy, because there's two of them. Okay, so there's two of those xy's. And then we've got plus the y squared. So I want you to look at the commonalities here between x plus y squared giving us this, and x minus y squared giving us this. Pause the video for just a second and pay attention to similarities and differences between those two. Okay, so I'm going to move on. So we're going to look at a few special products. That was one of them, or two of them actually, what we call perfect square trinomials. Perfect square trinomials. So those were of the form, that one and that one. That's what we just got up here. So pause again and take a look at those and see if you see the patterns. Okay, some others that we're going to look at is a difference of squares, a squared minus b squared. A sum of cubes, a cubed plus b cubed, and a difference of cubes. Those are special products and factors that we are going to see a lot, and you just need to memorize them. Also, knowing your first 12 perfect squares as soon as possible would be very helpful. And what I mean by that is, what is 1 squared? It's 1. What is 2 squared? That's 4. 3 squared is 9, and so on. So know those all the way up to 12. Squared is 144. All right, so factoring a perfect square trinomial. So we just worked it the other way. We multiplied, and now we have to know the factoring. Multiplying is easy because you can just FOIL it and figure it out. But factoring, if you can recognize that this is double this one times this one, right? This one times this one, and the middle term is double that, and the two terms are squared, then you can see that you've got a perfect square trinomial. Notice the minus sign is here, and this one is plus. Both of the b squareds are plus, because when you square negative, you get a positive, and when you square positive, you get a positive. All right, so here's an explanation of that, but we're going to practice it. So remember, the middle term is twice the product of AB. All right, so let's take a look at this. Factor the following. Okay, so I'm going to rewrite this so that you can see what is squared. So this is, and I don't mean factor it, I just mean write each individual first and last term as something squared. Okay, so 16x squared means we've got 4x, and that has been squared. And then we've got 2 times 8x, and we've got 2 squared. All right, so what you want to look at is, here is our a term right here, and here is our b term right here. Is this 2 times a times b? 2 times 4 times x. Okay, so you can see that this is 2 times 2 times 4 times x, and that becomes 2 times 8x. So this whole thing is 4x plus 2 squared. So if you doubt it, come over to the side and let's do 4x plus 2, and we will square that by saying 4x plus 2 times 4x plus 2. Let's work it out. The first term is 4x times 4x, that's 16x squared. And then we get 2 times 4x, that's 8x. And then we get another 2 times 4x, that's another 8x, plus 2 squared is 4. So we get 16x squared plus 16x plus 4, and that was our original equation. So check, always check. All right, let's try the next one. So give this one a try. Pause the video and see what you can do with it. Okay, so hopefully you see that this is 5x squared plus, let's just think about, leave that one for just a second, and this one is 1 squared. That's a tricky one, that's 1 squared. So now, do you get 2 times 1 times 5 times x? And yes, you do. 1 times 5 times x. So this is our a term, this is our 2ab term, and this is our b term right here. So it is squared, and that is squared. All right, so let's factor this, and we're going to get that 25x squared plus 10x plus 1 is going to be 5 plus x, let me rewrite that, x, sorry, mistakes all over the place, 5x plus 1 squared. All right, and again, I would go over here, take a moment and square it. So you get 5x plus 1 squared is 5x plus 1 times 5x plus 1. All right, so let's square the first one. So first is 25x squared. The outside is 5x. The inside is 5x because it's times 1. And then 1 times 1 is 1. And we get 25x squared plus 10x plus 1, which is exactly what we were given. Okay, so this is our factored form. All right, let's try a different kind of shape of our formula. So now this one has a minus in it, and if you think about it, this looks like, let's jump back up here, looks like the second one. Okay, so does it? Let's make sure, because sometimes we can be fooled. Not right now while I'm trying to teach you, but sometimes you can. So does this look like a squared minus 2ab plus b squared? All right, so let's think about this. If we took this, it would become 7x squared, and this would be 3 squared, right? 3 squared. So if this is our a and this is our b, then 2ab would be 2 times 7x times 3, right? 2 times 7x times 3. So 2 times 7x times 3. All right, and that's going to be a minus. Why is it a minus? Let's see, how could we get a minus there? What would be happening over here? What would be happening over here? So pause that and just think about that for just a moment. So what this becomes is 7x minus 3 squared. All right, so why is it a minus? Well, the only way you're going to get a negative here is if you have multiplied something that's negative. All right, so something here has got to be a negative. So let's just check it out and see. So we get our first, if we multiply this out, 7x minus 3 times 7x minus 3, we get 49x squared. Our outside term is minus 3 times 7x, that's minus 21x. And then minus 3 times 7x is the inside term, that's minus 21x. And then negative 3 times negative 3 is 9. And look at that, that is where our middle term, that is negative 42x, and that's how it becomes negative, is because both of the 3's are negative. All right? So really, where would this have come from? Well, b must have been a negative 3 squared, because negative 3 squared gives us 9, right? Or positive 3 squared gives us 9. All right, so why don't you go ahead and try the next one? I'll leave that one there so you can try it. Pause the video and give it a try. All right, so we're going to factor this. What we want to do is see what this would be, 3x squared. And then over here, we've got 2 squared. But since there's a negative here, this must be negative 2 squared right there. It must be. So in the middle, we've got 2 times 3x times negative 2. And that is going to bring that minus out to the front. And that's how we end up with the negative right there. Okay, so this is going to be 3x minus 2 squared. And again, if you want to check, I'm just going to keep encouraging you to do that. 3x minus 2, because you'll get better and better at foiling, and you'll start to see patterns. So square the first one, 3x times 3x gets 9x squared. And then we've got outside is negative 2 times 3x minus 6x, and inside minus 6x. And last, we've got plus 4. And so we get 9x squared minus 12x plus 4. All right, so what you want to be looking at here, now that we've done a few of these, is what is the square root of this whole thing right here, right? Square root of 9 is 3, square root of x squared is x. What is the square root of the last term? It's 4. If there is a minus here, if there's a minus, then you know there's going to be a minus in between the two numbers over here, over here. All right, so let's try a different kind. So let's do a quick warm-up. X plus y times x minus y. Pause the video and work that one out. Okay, so if I'm going to do FOIL on this, I get x squared. And outside is going to be minus xy. And inside is going to be plus xy. And then the last is going to be positive y times negative y is minus y squared. So what just happened right here? What happens to the middle term? It goes away. And I get x squared minus y squared. So this is a very important back and forth that you need to be able to recognize really easily, because we see it all the time. So this is called a difference of squares. A squared minus b squared factors out to be a plus b times a minus b, which we just showed going in the other direction. All right, so confirm that the first and the last are perfect squares, and it has to be a difference. It does not work with plus. All right, so let's try this. 16x squared minus 9. So let's just follow the rule and let's think about the first one is a perfect square, 16, and then a perfect square, x squared. And the second one is a perfect square. And the key here also is that there's got to be a minus in between. So this is going to factor to the square root of the first one, 4x, plus the square root of the second one, 3, times the square root of the first one minus the square root of the second one. And if you want to try working that out, I would definitely pause and work it out and see that you get back to that. You'll see that the middle term disappears by canceling out, by subtracting out, just like it did there. All right, so why don't you try the next one? All right, so hopefully you gave that a try, and we're going to take the square root of this whole thing. They're both perfect squares multiplied together. So what is the square root of 25x squared? It is 5x plus, what is the square root of 36? 6. And then we're going to take that times the same 2, but with a minus in between. And again, let's just work this out one more time. 5x times 5x, 25x squared. Outside, minus 30x. Inside, plus 30x. Last, positive 6 times negative 6 is negative 36. These two cancel out, and I just get 25x squared minus 36, which is what we started with. Okay. Can you factor a squared plus b squared? No, you cannot. It does not work. There's nothing you can do to make the middle term disappear if there's a plus. So think about that one. Go back and try to prove that to yourself with these examples here. So again, the answer is no.